last video we learned about the basics of matrices. Now we're going to start looking at some matrix algebra. And the first thing we're going to look at is adding and subtracting matrices. And the two rules we have to look at first, rule number one that everybody will overlook, the matrices must always be the same dimension. They must have the same rows and columns, same number of rows and columns. And rule two, all you have to do is just add or subtract each corresponding element to the matrices. So just looking at an example, and let's just get right into it. First of all, number one here, all we want to look at, we have two square matrices. They are the exact same size, the exact same dimension, 2 by 2. That means we are allowed to add these. To add them here, all I have to do, first of all, my resultant, my answer, is also going to be that same dimension, 2 by 2. And all I need to do, I add the top left entries, add them together to get 3. That's what goes in the top left. Add the top right, 4 and 8, gives me 12. Add the bottom left, that would give me 1. Add the bottom right, which would give me 5. That is my resultant matrix, and that's all I need to do, is just add each one. In number 2, same idea, except now I have subtraction. Again, I should check and make sure. I have a 2 by 3 matrix, 2 rows, 3 columns. Same here, 2 rows, 3 columns. So that means my answer matrix should be the exact same. And I'm doing subtraction. So 3 minus 1 gives me 2 in the top left. 0 minus 1 gives me negative 1 top middle. 2 minus 4, negative 2 in the top right. 7 minus 3 is 4. 5 minus negative 2 gives me a positive 7. And negative 8 minus 3 gives you negative 11. And again, you should notice still 2 rows, 3 columns for that resultant matrix. And number 3, what's going to happen here? Well, we have a 2 by 2 matrix, and then we have a 2 by 3 matrix. I cannot add this. I cannot combine this at all, so this just is a no solution here. What a lot of people will try to do is maybe add a row of zeros there. You cannot do that. Do not try to add any zeros to make your addition or subtraction of matrices any easier. The other thing we want to look at real quick is scalar multiples. And all scalar multiple is, same thing, just kind of looking here, we have a couple matrices. If I want to say, here's a matrix A, and I want to know what 4 times A is, well, all I need to do is literally multiply each element in the in the matrix by this coefficient 4. So 3 times 4 is 12, 0 times 4 is 0, negative 1 times 4 is negative 4, 2 times 4 is 8, then negative 8, and positive 20 for my entries here. Same here, I can do it. This is a 2 by 2 matrix. So 4 times 8 is 32, 1 times 8 is 8, negative 1 times 8 is negative 8, negative 4 times 8 is negative 32. So there's a resultant there. I can also multiply by fractions, or really even technically divide by numbers if I want to as well. So 4 times a half is 2, 1 times a half is a half. That means negative 1 times a half is negative 1 half, and negative 4 times 1 half is negative 2. So I can do scalar multiples as well, and even what I could do is maybe I could go and take these two that I just created, and I can add them together now. They are still the same dimension, so I could add 8b plus a half of a b, and end up getting this resultant matrix, whatever it is. 32 plus 2 is 34 for the top left. 8 plus a half would be, well, 8 and a half. I can write it just like that. Negative 8 minus a half, so negative 8 and a half. And negative 32 minus 2 is negative 34. So I can do lots of different things, linear combinations and scalar multiples when I do these adding and subtracting of matrices.